Inside our backend application, as of now, we are using H2 database to store the products related information. As a next enhancement, I want to upgrade our backend application from H2 database to MySQL database. Of course, we can continue this course with the H2 database as well. But the reason why I want to move to the MySQL database is in real applications, developers, they will end up using some production ready databases like MySQL, Postgres, Oracle to give you the same feel of developing an real application. I'm trying to migrate to the MySQL database. If you are comfortable with the H2 database, you can continue with the same. Regardless of which database you are trying to use, the way we build the backend application business logic is not going to change depending on the database. That's why if you are happy with the H2 database, you can continue. Otherwise, you can try to move on to the MySQL database along with me. But don't try to use other databases like PostgreSQL, Oracle, because whatever scripts that I provide inside this SQL folder, they are going to work perfectly with the MySQL database. In case if you want to use Postgres or Oracle, you may face some issues and you may need to update the scripts to make them work. Just to avoid the same, I recommend you to use either H2 database or MySQL database. To set up that databases, we have various approaches. In real applications, the databases will be created with the help of cloud providers like AWS, Google Cloud, Azure. Once the database is set up by the database administrators, they're going to give you the credentials. The same credentials you can mention inside the application.properties and you can happily connect to the MySQL database. That is one approach. We're not going to follow that approach because when you try to create an database inside the cloud, it is going to attract some bill which I want to avoid. Since you are going to learn this course over a period of months, I don't want you to be end up paying unnecessary bills. That's why I'm not using cloud approach. And the second approach, which is most basic approach, is you can go to the MySQL website. For example, inside the MySQL website, if you go to the downloads, you'll have an option to download the MySQL Enterprise Edition for developers. So this is going to be free for learning, developing, and prototyping. If you click on this, it is going to take you to the Oracle page. And here, based upon your operating system, you can try to download these files and install them inside your local system. And with that, you're going to have a database running inside your local system. But this is very basic approach, which I also want you to avoid. Instead, I'm going to show you a better and recommended approach. We're going to set up the MySQL database with the help of Docker. There is a very good chance that you might have already heard about Docker. Let me give a very quick introduction of Docker. With the help of Docker, we can develop applications, we can build applications, microservices that can run anywhere. Before Docker, developers, they used to fight with each other saying that this application is working perfectly inside my system. I'm not sure why it is not working inside your system. Because to make a application work properly, a developer needs to take care of lot many instructions. For example, to create a Spring Boot backend application, the developer need to make sure to install a specific version of Java. He should also take care of installing Maven and required Spring Boot libraries. Usually, all these instructions will be documented inside project, but there is a very good chance the other developers, instead of installing a specific version, they may install some other version, which may result into some issues. To avoid all these kind of issues, Docker came into picture. With the help of Docker, we should be able to package our applications with all the required dependencies along with their version numbers. When we package an application with the help of Docker, such packages, we call them as Docker images. When a developer prepare a Docker image for his application, he can provide that image to anyone, and other developers, they should be able to quickly start the application with the help of Docker. So they'll take the image and they'll try to run that image as a Docker container, and they don't have to worry about the setup like installing the Java or any required libraries. Everything will be packaged and available under the Docker image. The other developers, they have to simply use that Docker image and run that image as a Docker container so that they can start using that Spring Boot application. Docker is an universal product. It is not specific to Java or React or Spring Boot. Docker is supported by all languages, all frameworks, and all libraries. Using the same Docker, we can also install other applications like MySQL, Kafka, RabbitMQ. Before Docker, everyone, they used to install the software products by manual installation. But with the help of Docker, Everything can be done with a single command. We're also going to see the demo of Docker as well. In case if you want to learn more details about Docker, I discuss about the same inside my microservice course. Once you're done with this course, you can enroll into my microservice course and explore the microservice world as well. Once you landed onto this Docker website, go to the products and click on this Docker desktop. So with the help of this Docker desktop, we should be able to set up Docker inside our local system. Let me scroll down, and here you have an option of download Docker desktop. So based upon your operating system, you can download this Docker desktop. Installing Docker desktop is very easy. You just have to click next and finish. Once the Docker desktop is installed, please make sure you are also creating an account inside this Docker website. It is going to be free to create an account. The same credentials you need to use inside your local Docker desktop. If you log in into your Docker account from your local Docker desktop, it is going to give some better experience. Once you install Docker desktop and open the same, this is how it is going to look like. As of now, there are no images, containers, volumes inside my Docker desktop. Don't try to worry much about these jargons. Since this is not a Docker focused course, I'm trying to avoid discussing about the jargons of Docker. Inside this Docker desktop, you'll be able to see as of now, I already logged in into my account. If you have not done it, please log in into your account. Once the Docker desktop is installed and set up, you can confirm the Docker installation as well by running the command docker version. This command is going to give some output like this, which confirms that the installation of Docker is completed successfully. Next, we need to run a simple Docker command to set up MySQL database inside our local system. The command is docker run -p, p means port. With the help of this p, we're trying to provide port mapping. By default, all Docker containers, they're not going to expose the traffic to the outside world. MySQL database, by default, it is going to start at the port 3306. Using the same port, we're trying to expose the traffic to outside of the Docker network, which means to the local system where we are trying to set up the MySQL database. If you don't give this port mapping, then though MySQL container is running inside your system, you can't access it from your Spring Boot application. That's why make sure you are giving this port mapping 3306:3306. I'm going to mention this command as well inside the GitHub README document. Inside GitHub repo, you can open the section 9 related folder, and inside the section 9, we are going to have the backend folder. Inside the backend folder, you're going to find a README document. Under that README document, I will mention this Docker command. After the port mapping, I'm trying to give a name to the Docker container. The name is EasyStore DB. This can be any value. After providing the name to the container, I'm trying to provide an environment variable. That's why I have mentioned -3. Using this environment variable MySQL_root_password, I'm trying to set a password to my database. By default, the root username will be root. That's why I'm not trying to override any username. I'm only trying to provide password with the value as root. The other environment variable that I'm trying to mention is MySQL_database. Right now, we're trying to set up the MySQL database server. Inside this database server, we want to create a database with the name EasyStore. Using the same database name, we're going to connect from our Spring Boot application. After providing these environment variables, I'm trying to provide some volume information with the help of these -v flag. With the help of these volume configurations, I'm trying to map my local folder, which is present inside users, EasyBytes, desktop, EasyStore-data, to a folder that is available inside the container. As of now, inside my desktop, I have a folder with the name EasyStore-data. Try to set up similar kind of folder inside your system and please give its path here. If you are using Windows, the path will be different, but for Mac users, this is how it is going to look like. Inside Windows, based upon where you are trying to set up the folder, like C drive or D drive, accordingly, the entire path will change. Once you define your folder location after the colon, you need to make sure you are mentioning the same exact folder like var lib mysql. This is the folder that is maintained inside the Docker image of MySQL database. So we are trying to map our local folder to the MySQL folder present inside the Docker image of MySQL. There is a reason on why I'm doing this. If you don't do this folder mapping, in future by accident, if you delete the MySQL container from your Docker desktop, And with that, you need to create the container again by using this command. And at that point of time, your database will be brand new database because your database stored all the information inside this MySQL folder present inside the container. If you lost the container or if you delete the container, the data also will be lost. But with the help of this volume mapping, we're telling to the Docker container, store all the information inside my local system at this folder. Even if you lost the MySQL container, you can try to run the same command again and your container will still have old data that you saved previously. But please make sure this folder that you are trying to map with the name easystore-data, it is not deleted inside your system. After this volume mapping, I'm trying to mention -d. -d means I want to run this command in a detached mode. I don't want to see any logs related to MySQL inside my terminal. That's the purpose of mentioning these -d. And towards the end, we need to mention what is the Docker image name. Since I'm trying to install the MySQL database, for this database, the image name is MySQL itself. For Oracle, it will be usually Oracle. For Postgres, it will be Postgres. Most of the products, they name the image name same as the product name. That's why I'm trying to use MySQL as the image name here. As soon as I execute this command, since the Docker image is not present inside your local system, first, Docker Desktop, it is going to download the image of MySQL into the local system. Once the downloading of the Docker image is completed, a Docker container is going to be created. So what is a container? It is a running instance that is going to be created with the help of Docker image. Let's wait a couple of minutes for this download to complete. Once the download is completed, a Docker container is going to be created behind the scenes, and this is the container ID. Let's validate if the container created successfully or not. Under the images, you'll be able to see the images that are downloaded into your local system. As of now, the command that we ran, it downloaded MySQL database related image, the same I'm seeing here. Let's go to the containers. Containers are the running instances of your Docker images. This is the container of MySQL database. Behind the scenes, a MySQL database is running inside my local system and it can be accessed at the port 3306. If I click on this container name, which is EasyStore DB, you'll be able to see all the logs that are generated during the setup of the MySQL database. So please make sure you're not deleting these container. In case if you're not using this container, you can stop the container and start it again when you want to use inside your Spring Boot application. If you delete this container, then again, you need to come and execute the same command, and you should also make sure this easystore-data is not lost inside your system. If you lost the folder and container, then you are going to get a brand new database and you may need to set up tables, data, everything from scratch again. This is my easystore-data folder. As you can see, all this data is created right now by my container. Whatever data and tables that I'm going to create in future, all such data will be stored inside this folder location. We're doing this because this is not a production setup of the database. Inside production setup, usually databases, they are going to store the data in some cloud file system or in some cloud storage. Since we want to avoid some cloud option, we're doing this everything inside the local system by following some techniques. MySQL database setup is installed. Let's try to integrate our backend application with this database from the next lecture.